Okay, we're going to do a little bit, start with statistics here. The population would be like, say, all DMAC students. So that would be everyone. And all DMAC students is a broad thing. A sample is going to be like if I take a little piece of all DMAC students, okay? And sometimes that can be easier said than done, all right? Random would be if I have all DMAC students and I just randomly pick, you know, person here, person here, person here, maybe using 900 numbers or something like that. And I randomly get a group of 100 people, okay? So that could be a sample. And a good sample needs to be random where, you know, like I just, I have a calculator that gives me random numbers like, oh, here's 1,000 numbers. I want to pick 1,000 student, or out of 1,000 people, I want to pick 100, and it gives me the 100 numbers, the first 100 numbers in random order. And I might pick person number 999, person number 14, person 36, and so forth. So random number generators, things like that. The problem with just doing a random sample, though, is like, for example, DMAC is kind of, you know, cut into three things. We have some high school students, which is concurrent enrollment. We have some students that are getting their, you know, AA, right? And then we have people that are getting an AAS or some type of certificate or tech degree. And so if you randomly do this, it's possible that you might get no high school kids. You just randomly get all these. Or AA is by far, you know, that's a chunk of people. Maybe we get all those. So sometimes we want a representative sample. And so the way we do this is we might look at the population. And so say with DMAC, say it's cut into thirds. So high school's a third, AA degrees, and then maybe tech is a third of our population, okay? So say that we have, you know, I don't know, 10,000 here, 10,000 here, and 10,000 here. Then what we would do is we'd look at the percentages, okay? So say we want a random sample of like 100 people, but say that, I'm just making up numbers here. Say that 40% of our students are AA. Say that, let's see, what would that be? This is 30. Let's make this a little higher. This isn't actually true though, but we'll deal. I just want the numbers kind of easy. All right. It's actually about a third, but we'll pretend that high school at some college, maybe it's not DMAC, 30%, 50% are AA, and 20% are tech. Say you want a random sample of, you know, like 100 people. Instead of just randomly grabbing 100, what you could do is do 30% of 100. And you would get 30 people that are concurrent enrollment or high school. Then we do 50% of 100. And that would be, we would want 50 people that are getting their AA. And then we do 20% of 100. And we would get that 20 people are getting tech or something like that. All right, then what we would do is we would go to the high school little area and we would randomly grab 30 names, okay? And then we would go to the AA, since they're a bigger percent, we would grab 50 random names. And then tech, since it's a little less, we grab 20 names from that area. And that kind of ensures that everybody's represented at the percent that they should be at, okay? So that's kind of a way to deal with that. All right, a frequency distribution is when you kind of make a chart to gather some of your data a little bit. So like say I ask like people their GPAs, and maybe someone has, you know, not doing so hot there, 3.6, maybe a 4.0, maybe a 5 point, well, no, not for GPA. How about a 2.5? That's better. And maybe someone has 2.8. And I'm not doing like a lot of digits here. Maybe we have a 3.9 and so forth. Okay, a frequency distribution is when you make kind of a chart and you organize the data. So maybe over here we have GPA and then we have frequency, okay? And so I might do from 0 to, let's see, like a 0.9 maybe, and then 1, 2, so if I add, that's what, so 1.9. All right, and again, you have to count the ends, but some people could have a 0 GPA. So 0 to 1.9. So notice if I subtract these, I get 0.9, subtract these, 0.9, and then start, and I get 2.9, and then 3 to 3.9, and all right, maybe I should pick different numbers. 4 to, there is no 4.9, but we'll just, because your gaps have to be consistent. And then what you do is count these. And sometimes we use tally marks. So we do like, okay, 1.2 goes there, 1.9 goes there, 2.4 goes there, 3.6 goes there, 4.0 goes there, 2.5 goes there, 2.8 goes there, and 3.9 goes there. And then, so that would be just kind of like a tally. And then your frequency is when you count it. So you'd be like, okay, 0 there, 2, 3, 2, 1. Okay. A lot of times we do this, yeah, because there is no 4.9. Well, at University of Iowa, actually, you can get a A plus, a 4.33, but you can't get a 4.99. So this doesn't, I have to make these the same width, but that wasn't very good. So let's do something else. Temperature. Temperature is a great idea. So say we do the temperature in a certain month, and it's like 10 degrees and 12 degrees and maybe 30 degrees and 41 degrees and 32 degrees and say 17 degrees. And maybe a 9 degree, 8 degree, and 13 degree, and maybe 42 degrees, 17 degrees, and 22 degrees. Okay, so a frequency chart would be when you would do temperature, and again, if you want to do tallies, it makes it faster, but then we ultimately really want just frequency. But again, these have to be equal width. So if you go 0 to 9, okay, notice that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 numbers. That's a width of 10. So if I start at 10, I would go to 19 because 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 is a width of 10. So then all of these have to match 30 to 39 and then 40 to 49. Okay, and again, you could try to count them, but sometimes you screw up. So I'm going to do tallies. 10 is a tally, 12 goes there, 30 goes there, 41 goes there, 32 goes there, 17 there, 9, 8, 13, 42, 17, and 22. All right, so frequency would be 2 of these. What is that? 5 of those, 1 of those, 2, and 2. Okay, and there you go. If you graph this, this is called a histogram. So if I graph it, they're going to touch because once you get out of one temp, you go into the next range. So I'm going to make these equally spaced and they are going to touch. So like this is 0 to 9, 10 to 19, 20 to 29, 30 to 39, and what, 40 to 49. And make sure in graphs you label. So this is degrees Fahrenheit. Okay. And then frequency goes over here always. And then a title like, I don't know, temperatures in February or something like that. Okay. And then you make your bars. So I need consistent. What's my highest? 5. So 1, 2, 3, 4, 5. I only have 5, so I can go by ones. If I had bigger numbers, I could go by 2. So like 2, 4, 6, 8, 10. If I had bigger than that, I could go by 5s, 5, 10, 15, 20, 25. Or I could go 10, 20, 30, 40, 50. So the number, how high these are kind of determines that. All right, we're going to go to 2. So go 2 high. This one goes 5. And your bars should be the same width. And then we go down to 1. And then we go to 2. And then we go to 2. Okay? All right, and that is a histogram. It's not a bar graph. Bar graphs are more categorical, meaning like you have categories, not number things. So like if I count green M&Ms, red M&Ms, and blue M&Ms, right? And say this one went by 10s, 10, 20, 30, 40. And this would be like M&M, I don't know, distribution or something like that would be the title maybe. All right, so say when I count my green M&M, say I have 32, so I'm just going to go a little bit above 30. And then when I count my red M&M, say I have 9, so just a little bit. And again, they should be the same width, but they shouldn't touch. And say blue, I have exactly 40. All right. This is a bar graph because they don't touch, because once you're not a green M&M, you don't suddenly become a blue one. So these are categorical. So you just kind of spread them out. You still have like a label here, like, you know, color of M&M, and then this is your frequency. Histograms are number ranges. And when you get out of one, you go into the next. So that's why they touch. Stem and leaf is, let's take this data. And these are data items here. A stem and leaf is you make a stem and you make a leaf. And so like these are zeros, 1, 2, 3, 4. And that doesn't really stand for, well, that stands for 0 in the tens position, but that stands for 10, 20, 30, 4. So this is your tens. and this is your ones. So what I'm going to do is, now I'm going to put these in order first because you don't want to, these have to be in numeric order. So I'm going to go 10, 12, what else do I have? An 8 and 9 would go before that, 8 and 9. So 8, 9, 10, 12, 13 would go there, 2 17s, 22, 30 and 32, and 41 and 42. Okay, so what you do is you look at your ones, and you have 8 and 9. So you put them, it's like a bar graph, you space them out though, 8 and 9. And then we have what, 0, 2, and 3. So this is 10, so it's 1, 0. So the 10 is from over here, 1, 0. 12 is 1, 2, and oh shoot, I need more space, Julie. All right, we're gonna have to start over here. So 0, 1, 2, 3, 4, and then, so this is my stem, this is my leaf, and this is 10's position, and 1's. All right, need more space. Okay, so 8 and 9 I had, so I'm gonna space those out. And I had 0 and 2, so 0, 2. But then I also have 3, 7, 7. So, and again, space them out equally because it's like a bar graph. Okay, then I have 1 for 22, 30, so I have a 0 and a 2, and a 1 and a 2. Okay, so these should all line up. And so in a sense, it's like a bar graph if I turn it sideways, kind of. But you can see the data like 8, 9, 10, 12, 13, 17, 17, 22, 30, 32, 41, 42. And again, this would just be like temps in whatever month we said. Stem and leaf can also be decimals. So this could be like the ones and the tenths. Okay, and this is my stem, and this is my leaf. So where did I do those GPAs? I don't know if I have those anymore. All right, so those GPAs I did earlier, let me put those in order. It'd be what, 1.2, then what, a 1.9, and a 2.4, a 2.5, a 2.8, then I think a 3.6, a 3.9, and a 4.0. All right, so what I do here is, this is my ones position. Now say I'm going to add another GPA. Say someone had a 0.9. You would do a 0 first because that's in the ones position, and that's my tenths. So this would be 1s, 2s, 3, and a 4. And even if you have a big gap, you list them because you want to see that it's an outlier. So this is a 9. This is a 2 and a 9. And again, space them evenly. 4, 5, 8. 6, 9. And then what? A 0. All right, so this is 0.9, 1.2, 1.9, 2.4, 2.5, 2.8, 3.6, 3.9, and 4.0. So stem and leaf can work like that as well. All right, let's talk about mean, median, and mode. Mean is fancy for average. And mean formula looks like this. Add up all your data points, all your x's, and divide by n, your number of items. So, you know, if you have like 3, 4, and 5, you could just add those up, which is what, 7, 8, 9, 10, 11, 12, divide by 3, and the average is 4. And we usually use that symbol, a little X with a bar on it. That's your average. Now, but what does the average really mean? The average actually means kind of steal from the rich and give to the poor, kind of an average, like a Robin Hood, like if these are balanced. So one way to think of it is if I had towers, like 3 high, 4 high, and 5, and I wanted to balance all my towers out, I could steal from the 5 and give it over here. So I could steal 1 and give it over here. That's what average means, okay, is that you're getting them all balanced out to the same height, okay? Now, sometimes it's easier, you know, obviously just to do this math, but that's what's really happening there. So an outlier can really mess that up, because if you have this and you divide by 3, the average is what, 7, 21 divided by 3. But if you think about it, you know, one tower is 20 tall, then this person got a 0, and then this person's only got a 1, right? So the average is kind of misleading because it doesn't look like these are all 7, right? People think average means all the same. No, when you steal from this big one, you can make them all the same. So if I take, you know, what, 13 from this guy will be 7, and then this guy's 13. And then if I steal 7, oh, maybe not 13, is that going to be 14? Yeah, 14. Then I make this guy a 7 and give that 7 over here. That's what it means. All right, I think we're done. I'll put more stuff on the next video.